Okay, we started out the unit, we talked about the history and structure of the atom. Okay, so in the multiple choice, you could probably expect some questions that deal with the different models. Okay, like I maybe show you a picture of a model and you have to tell me whose it is. Related to this, there could be some multiple choice questions about the structure of the atom, like where are certain particles? Okay, where would you find protons? Where would you find electrons? In this particular atom, how many protons would there be? Okay, things like that. That would totally be multiple choice type question. There is also a written response question, okay? And I spoiled this one on the first day, so I'll spoil it again. I am going to ask you to draw a picture of an atom. I will tell you which one on the test, okay? You have to draw it the correct model. You got to put everything in the right place, and you have to have the right number of protons, neutrons, and electrons. 5-mark question. Okay, the right model, everything's in the right place, the right numbers of protons, neutrons, and electrons. Okay. On that diagram, I would suggest having a legend. Okay, so that I know which are protons, which are neutrons, and which are electrons, because sometimes it just looks like a bunch of circles to me when I look at people's pictures of the atom, okay? So, what would be smart would be a circle with a plus sign in it would be a proton, okay? Those, the obvious kinds of things. But have a legend there, because if I have to guess, I just guess that it's wrong. Okay, that's where I have to go as a marker, so leave no doubt. Okay, Mr. Coderre, this is a proton. Mr. Coderre, this is a neutron. Okay, so that I know what I'm looking at, and then you get your full marks because I'm not confused. Okay. All right, so draw a diagram. Okay, correct number of particles, right model, everything in the right place. 5 marks. Pretty easy written response question for 5 marks. Okay, naming compounds. This is in every part of the test. Okay, specifically the multiple choice goes, what's the correct formula for this compound? Or what's the correct name for this compound? Yes, those are definitely going to be multiple choice type questions. So explicit naming questions in the multiple choice. But do you need to know how to write formulas and name compounds for the written as well? Yeah, okay, because I'm going to ask you to write chemical reactions. You have to be able to get the formulas right in order to get the reactions right. So in that way, it's part of all parts, okay, of the exam. Just explicitly tested, okay, in the multiple choice with those kind of questions. But obviously you have to know how to do it to do other parts of the test. Good? Yeah. Okay, so definitely know that, okay? Am I probably going to use ones that have Roman numerals, things like that? Okay, I got to check all the naming rules, so make sure you know how to do it all. Okay, properties of compounds. Okay, we did a lab on properties of compounds. We tested a bunch of unknowns and we figured out what their identities were based on their physical properties. Expect there will be some multiple choice questions about that. Okay, so definitely go over lesson 4 and your lab. The way I would maybe test that on a multiple choice question could be, you have an unknown sample that is a pink crystalline solid that is highly soluble. Its solution is highly conductive of electricity, has a pH of 6. It would likely be A, carbon dioxide, B, copper 2 sulfate, C, cobalt 2 chloride, or D, ammonium nitrate. Which one would it be? The cobalt one, because it was pink. And it was obviously ionic because it conducted electricity. Okay, it's not a gas, so carbon dioxide was definitely out. Okay, things like that. I could definitely ask a question like that that asks you, do you remember the things that are in lesson 4? Because all of those things would be in lesson 4. Ionic compounds conduct electricity in solution. Okay, they're all crystalline solids at room temperature. There's a few metals with special colors. Right, that kind of thing. That's how I would ask that. Okay, I might also ask more generally, which of the following is a property of molecular compounds? Okay, A, always crystalline solids at room temperature. B, highly soluble in water. D, don't conduct electricity in solution. I don't know what another one, but okay, you get the idea. It would only be C, okay, because they don't conduct electricity in solution. Okay, something like that. Okay, it could be more general. So definitely have a look over the notes for lesson 4 as well as your properties of compounds lab for those questions. Okay, solubility. So that would be lesson 7, which is solubility in the polar nature of water. All right, there's a lot of terminology tested in the multiple choice. So what's a precipitate? Okay, what's a heterogeneous or homogeneous mixture, or those kind of things. Know the terms, okay, so that you can answer those questions. Will I ask you to use your solubility chart? Okay. More than likely, I would write a chemical reaction and ask you which of the products are soluble, okay? Which is exactly what I asked you to do in analysis question number 2 on your reactions lab. Okay, I'm going to ask exactly the same thing. Here's a chemical reaction. Tell me which, if any, of the products are soluble. All right, so you have to look it up, okay, and see. Maybe they're both soluble. Maybe neither one is soluble. Maybe just A or maybe just B. Okay, everyone follow there? And then there is going to be a question that's kind of meant to separate the wheat from the chaff, okay? And by that I mean it's hard, right? On every exam there's going to be one question that really makes you think, because it's not a situation that I've directly covered, okay? It's what we call a synthesis question, right? You have to take what I have taught you and apply it to a situation that you've never encountered before. Okay, that's a high-level thinking question. So they tend to be the toughest kind. Okay, you're going to have to take what I've taught you and figure out, okay, how can I apply this, okay, to this particular situation? And I will tell you that it involves solubility and chemical reactions. Okay, so those two concepts would be highly likely, okay, to be in that problem. Okay, so that's what I was just talking about there. There'll be an application question about solubility and chemical reactions. Okay, polar nature of water. So you'll need to be able to tell me what a polar molecule is, okay, or what it means to be a polar molecule. some of the behaviors that a polar molecule would display, like hydrogen bonding, causing cohesion and adhesion, okay? That would be important. And then a place where you've seen that applied, okay, or where it might apply. Okay? The ones we talked about were how a plant can transport water up its stem, or the Jesus lizard running across a pond, okay? Things like that, or places where the polar nature of water, skipping a rock across a lake, okay? All of those kinds of things. Okay, if you're a polar molecule, what does it mean? Something about the electrons. Are they equally shared? Okay, you guys better go over this. Okay, in a polar molecule, electrons are not shared equally. That makes one side positive, one side negative. That's what causes the hydrogen bonds. Better go over lesson 7, second half of it. That's where you'll find that stuff. Okay, super important that you know that on this test. Okay, so explain what a polar molecule is, okay, hydrogen bonds, how that's used by living things, okay, that kind of stuff. Okay. Biggest concept on the test, worth more marks than anything else by a fair margin. Okay? Chemical reactions. All right? There are some reaction questions in the multiple choice. They are mostly about reaction types. So I give you a reaction and then A, B, C, or D. This is an A, double replacement reaction. B, combustion reaction. C, single replacement. D, decomposition, and you have to pick. Okay, so pretty simple. You just have to know the reaction types for those. There's a couple of multiple choice about that, right? This is no longer in the written response. This is now in the numerical response. Okay, balancing. There are 7 reactions that need balancing in the numerical response. Okay? How many people have done numerical response before? Okay, so you're pretty familiar with that. Okay, the way it'll work for the balancing ones is I give you a reaction. Okay, so let's just say it's something simple like HCl, okay, plus NaOH, and it gives H2O plus NaCl. Okay, so this reaction is already balanced, right? But it would have blanks in front of each of these. All right. Well, obviously, what goes in each blank is a 1 because it's already balanced. So in your numerical response section, okay, you'll have a box like that, and then you'll have the shade in stuff underneath. Okay, and they'll have the numbers in them, so 1, 2, 3, 4. Okay, so you'll write 1, 1, 1, 1 up there, and then you'll shade in all the ones. Okay, that's how the numerical response will work. Very straightforward. Okay, and then obviously in the written response, there are, okay, 4 reaction questions where you have to write them out, identify the type, okay, balance, and predict products. mistake this. There are only 3 written response questions, but my numbering thing crapped out and it said 1, 2, 4. So I said there were 4. There are 3, but 2 of them have A, B, C, D. Okay, so there's like actually 9. Okay, but okay, and so there's an A, a B, a C, and a D that are reactions. We only went over 5 types, so there's only 1 that's not in there. Okay, where you'll have to identify the type, write it out, write out the reactants, predict the products, balance. 4 marks each. Okay. All right, and then there's mole equation. Okay. This one is supposed to be this one. Okay, there's 4, 1 of each type. Okay, expect that you'll see 1 of each type of mole equation question on your unit exam. Okay, using the bubble sheets, because this happens all the time and I don't know why. Okay, so the purpose of using ZipGrade and using the bubble sheets is to save me time. Okay, so it's to save me time. I am not going to manually check your machine scored sheets. I'm going to hold my phone over them and my phone is going to mark them. My phone's always right. Okay, so here's what I don't want you to do. First, I want you to bring pencils. That's plural. Notice there was an S at the end. Bring more than 1 pencil, okay, in case one breaks. Because you need to do these in pencil so that you can erase. So here's my suggestion. You've got your bubbles on the bubble sheet, okay, and they have the letter inside. So my suggestion is, if you think it's B, just put a little dot inside of B. Don't shade the whole thing in hard, okay? Just put a little dot in the middle. That way, if you're going over your answers later and you want to make a change, that little dot is easy to erase and my phone won't mistake it for a correct or for an incorrect answer. Okay? Here's what you do not want to do, but I see it all the time anyway. Okay, someone like, oh, it's totally B. I know it's B, and they shade that thing in good and dark. Okay, and then they're like, oh, no, it's not. You're laughing because you watched the thing, right? And I did this before. Okay, and then you go like this, and you're like, no, it's totally D, and you fill it in good and dark, and then, oh no, shoot, no, it's not that one, and you cross it out, and you do this, and you shade this one in, and then you do this. This one. Okay, when my phone sees that, do you know what it's going to say? That that's wrong. Do you know what my phone is when it says that's wrong? Right. Okay, that is 3 answers. None of these questions have more than 1 correct answer. Erase it. Okay, do not do that. That's just wrong. Okay, just wrong. In so many ways, not just like incorrect, but just wrong generally. Okay, so don't do that, please, please, please. Okay, just shade it in a little bit, then when you're done, fill it in good and dark when you're sure about it. Okay, the same goes for the numerical response. Now, I talked about 1 type of numerical response, the balancing, so there'll be 7 of those balancing ones that you'll have to fill in. Okay, but there's also a couple that go like this. Okay, I'll have a list of concepts from this unit. So like, I'm just writing things down. These may not necessarily be on the test. Okay, on your test there's actually 8 concepts. I'm just writing 4. Okay, and these may not be the ones that are on your test anyway. Now, the way these questions will work is there'll be a little blurb, a little story to read. Okay, you read the story and then it'll say which of the concepts from the list apply in this story? Okay, write them down in increasing order. All right, so if you thought, after reading the story, that the two concepts involved in the story were cohesion and hydrogen bonds, okay, there would be, on your numerical response, okay, okay, one of these, but it would go to 8. Okay, you would go in there, okay, I thought it was cohesion and hydrogen bonds, 2 is smaller than 4, so I'd go 24, shade in 2, shade in 4, there's my answer. Okay, there are a couple of questions like that on your exam. Okay, they're numerical response, but they're saying what things from that list were talked about in this story. Okay, everybody with me there? Okay, so it's not really a number thing, it's kind of like a multiple choice question that has more than 4 options, but more than one of them is correct. Okay, so for any particular question, there could be one that's just, there's only 2 concepts, it'll only have 2 options. Okay, if there's one that says there's 4 concepts in this question, then it'll have 4 spots, and you have to pick the 4, and you write them in increasing order. So if you thought it was 1, 5, 7, and 8, then you go 1, 5, 7, 8. Don't go 5, 1, 7, 8, then it'll just be wrong. Okay, it's got to be in numerical order from left to right. Okay, and it says that on the test. The instructions are on there. I'm just kind of giving you a heads up now. Okay. All right, that's what's on there. Okay, how many people did the practice test already? Okay, expecting more hands up. All right, well, maybe you want to do that tonight. I don't know, your test is tomorrow, so you can do it tonight or it kind of moves at that point. Any questions? Anything you'd like me to go over in more detail? Do another example of?
There's a question on the practice test that I wasn't too sure of.
Okay.
This question.
Chlorine ion. Okay, so chlorine ion Cl1 minus. Okay, that's a good question. I like that one. Okay, so chlorine ion Cl minus 1. All right. The options are, has lost a proton, gained an electron, I don't know what the other ones are, lost a neutron or something like that. It's multiple choice, right? Okay, so to get a charge of -1, what has to happen to that atom? Just to gain an electron, yeah. Okay, so does that sort of make sense? Okay, it's kind of a structure of the atom question, like what parts of the atom can change in number versus what can't. Okay. Any other ones? They don't have to be from the practice test, guys. If there's something you want me to do another example of, happy to do that.
Do you have like one with like the atomic mass, like subtracting it?
Finding the number of neutrons?
Yeah.
Yes, okay. All right, so potassium, let's say. Okay, so that could very easily be a multiple choice question, right? How many neutrons are in this? Or it could be part of that that whole draw a picture of the atom question, because you need to know how many of everything there are. Okay, so just quick review. Okay, the atomic number tells us which 2 particles? Protons and electrons, because those have to be equal in number, right? Okay, atoms don't have a charge. So there's 19 protons in a potassium atom. There are 19 electrons in a potassium atom. How many neutrons are there? Well, to find the neutrons, we take the atomic mass, 39.10, and we subtract the atomic number, 19. All right, so that should give me 20.10 if my math is correct. Okay, how many neutrons in a potassium atom then? 20. Yeah, because you can't have 0.1, right? You can't have 0.1 neutrons, it's just 20. Now, what if that was 20.7? Then round up to 21. Okay, I can't think of an atom where that happens. It's almost always less than 0.5. Okay, so yeah, just know that one. Yeah, I mean, if it comes out to like 20.99, that can happen. You can be really close to the upper end, but it's almost never in the middle. Okay, like you're never going to get a 20.49. Okay, like you're not going to get that. Okay, it's either gonna be very obviously going up or very obviously going down. Okay, in this case, it's very obviously going down. All right, what else?
What is the difference between the H plus and H minus?
H plus and H minus. Okay, so hydrogen, because it's so simple, can fill its outer shell in one of two ways. It can lose its electron, okay, and if it loses its electron, it's H plus. Then it has no electrons. It's just a proton floating around, okay? That's what it does most commonly. But you could get it acting as a nonmetal. When it acts as a nonmetal, it's very rarely like an ionic nonmetal. It's almost always in like a combustion reaction as something in there. Okay, but you would know it's -1 if it was in something like that. It's listed second, so it's acting as a nonmetal. Okay, that sort of make sense? Okay.
For the practice test, it's kind of the last one.
Okay.
One of the written ones.
Okay, so that would have been a wheat in the chaff kind of question.
Yeah.
Yeah, okay, so you've got this compound and it's in the drinking water, right? Okay, it was mercury, what? This mercury
Nitrate?
nitrate, okay. So mercury nitrate is soluble in water, okay? And without giving this away, you gotta find some way to get it out, okay? Think about reactions and solubility and how you would get that out. Is there a reaction you can do, okay, that would help in a solubility way to get that out of the water, okay? It's not the nitrate that's toxic, it's the mercury, okay? Nitrates are fairly harmless, but mercury is a heavy metal, okay? That is toxic. That has to come out. Okay, in water treatment plants, they have a very simple solution to this that I'm not gonna give you because it is basically the question, okay? But I'm telling you, reactions and solubility are the two concepts. Is there a way to use a reaction, okay, and get a solubility thing to happen that would get that out? Okay, probably wanna use some terminology related to solubility, okay, in that question, right? And that would give you the answer. That's actually a numerical response question now. It's no longer a written like that. Okay, so it's one of the ones where you're picking your numbers, okay, which concepts are important. Okay, sorry, no, that's not the answer you were looking for, but that's the one I want you to think about, okay? All right, what else? No, you look like you're halfway up. Okay, well, if there are none right now, here's what I want you to do. Work on the review. Okay, if you need your phone out to access the paper, that's fine. Okay, you bring that up on Google Classroom, I'm okay with that. Okay, work on that for now. If something comes up while you're working on it, then you ask me the questions. Okay, we'll continue to go over more on the board as needed, okay? But you've got the rest of the class here to prepare for tomorrow.